Let me ask you something. What if the empty space between the stars wasn't empty at all? What if it was a real physical substance, like a kind of invisible crystal that fills everything? I know, it sounds like something straight out of science fiction, but a radical new theory is proposing that this invisible crystal might just be the one clue we need to solve some of the biggest mysteries in the entire universe. You see, for decades, our best theory of the universe, what we call the standard model of cosmology, has been an absolute champion. But lately, well, it started to show some serious cracks. It's like we're cosmic detectives and the clues just aren't adding up anymore. And the prime suspect might be the one place we never thought to look, the vacuum of space itself. So let's start where any good detective story does, at the crime scene. The evidence is piling up, and it all seems to suggest that our understanding of the universe is fundamentally broken. And we're not just talking about a small crack here. This is a deep foundational fracture. It's so serious that it forces us to ask a really uncomfortable question. Are we completely wrong about how the universe actually works? Okay, so here's our first major clue. It's something called the Hubble tension, and it's a real head-scratcher. When we look at the leftover glow from the Big Bang, the early universe, and use our model to predict how fast things should be expanding today, we get a number around 67. But when we go out and actually measure the expansion rate of the universe around us right now, we get a totally different number, something closer to 73. These two numbers should match. The fact that they don't by a long shot is a huge problem. And it doesn't stop there. The mystery gets deeper with our second clue, the S8 tension. Our standard model predicts that all the matter in the universe, galaxies, clusters, all of it, should be clumped together in a very specific way. But when we actually look out there, the universe is smoother. It's less clumpy than it's supposed to be. This tells us the problem isn't just a fluke. The whole system has cracks showing up everywhere. So, if our main suspect, the standard model, has an alibi that's falling apart, we need a new one. And this is where a truly mind-bending idea comes into play. A theory called Vacuum Elastodynamics, or VED for short. So what on earth is VED? It proposes that the vacuum of space isn't just nothing. It's a real physical medium. They call it a supersolid. And that means it has properties of both a solid, like having a rigid structure, but also a fluid, which allows stuff to move through it without friction. It's a completely new way to think about the actual fabric of reality. And this theory gets incredibly specific. The scientists behind it say the vacuum is a hyperuniform elastic solid. Now, hyperuniform just means it's perfectly, almost unnaturally orderly. And it's not just any old crystal shape. It's a very special mathematical structure called an E8 geometry. The main takeaway here is pretty wild. The theory says our universe is built on top of a perfectly hidden crystal. Okay, but that brings up a giant question, right? If space is literally a crystal, how have we never, ever noticed it? How could this possibly be true without just completely demolishing everything we know about physics? I mean, this is the big one. A physical grid filling all of space? That seems like it would have a preferred direction, a kind of grain to it. And if that were true, it would instantly violate one of the absolute cornerstones of modern physics, Einstein's theory of relativity. The specific rule at stake here is called Lorentz invariance, and it's a beautiful idea. It just says the laws of physics are the same for everyone, no matter if you're standing still or zooming through space. A crystal in space would seem to create a universal rest frame, a fixed background we could measure our motion against. We've never detected anything like that. So, for VED to even be considered, it needs a rock-solid airtight alibi. And unbelievably, the theory provides one. It's a brilliant four-step explanation for how this crystal stays completely hidden. First, remember that special E8 geometry? It's key. Second, that unique structure can be split into two perfectly mirrored interwoven subcrystals. Imagine them perfectly balanced against each other. Third, this perfect balance creates something called a topological lock. It's a fundamental mathematical rule that just can't be broken. And that leads to the crucial final step. This rule makes it physically impossible for any experiment we could ever run to detect a preferred direction in space. The crystal's perfect symmetry completely cancels itself out from our point of view. It's there, but it's perfectly, mathematically, invisible. Okay, so the alibi is established. The crystal can exist without ever seeing it. Now we can finally get to the climax of the story, the single dramatic event that VED claims solves both of our cosmic mysteries in one fell swoop. This chart right here, This is the heart of the entire theory. It's basically the life story of the vacuum's physical properties. Way back in the early universe, what's labeled Epoch 1, the vacuum was like a frictionless superfluid. Then, at a specific point in history, a critical event happened, a phase transition. The universe expanded just enough that the vacuum suddenly jammed up and crystallized. It became a solid, settling down into its current state, Epoch 3, a viscoelastic solid, which just means a solid that has a little bit of friction to it. So let's just break that down one more time. In Epoch I, the universe was expanding super fast, like a puck on frictionless ice. Then came the big jamming event. The vacuum locked into a solid, and in that process, it released a ton of stored energy, which we now call dark energy. And that brings us to today, Epoch 3, where this solid vacuum has a tiny bit of friction, or viscosity, that affects everything moving through it. So how does this one event solve our two clues? First, the Hubble tension. VED calculates that the universe was expanding faster in the past, around 74.7, just like some measurements suggest. The jamming event hit the brakes. This new lattice friction slowed the expansion down to the rate we measure locally today, around 72.7. So both measurements were right, they were just measuring different eras. Second, the SA tension. Well, that same friction creates a kind of cosmic drag on matter. It makes galaxy clusters look less clumpy than they actually are. The SA tension isn't a real problem, it's just an optical illusion. I mean, one single event that solves two massive problems in cosmology is already incredibly impressive, but the explanatory power of this theory actually goes way deeper. And this is where it gets really mind-blowing. This is the smoking gun. The gray points on this chart, that's real data from supernova observations. That's what we actually see. Now that red line, that is not a line of best fit. That is the theoretical prediction calculated from the VED theory itself. There are no knobs to turn, no parameters to tweak. It's a pure prediction. And it threads the needle perfectly through the real-world data. That is just stunning. Now, let's talk about another huge problem in physics. It's called the vacuum catastrophe. For decades, our best theories have predicted that the energy of empty space should be larger than what we observe by this number, a 1 with 122 zeros after it. It's famously been called the worst theoretical prediction in the history of science. VED looks at this and suggests it's just a simple misunderstanding, a category error. Quantum field theory predicts the immense stiffness of the vacuum itself, the container. But when we look out with our telescopes, we're measuring the tiny residual stress inside that container, the contents. It's like confusing the incredible strength of a steel beam with the tiny amount of tension in a guitar string made from that steel. When you realize you're measuring two different things, the 12 order of magnitude problem just evaporates. So let's just put it all together. This scorecard really says it all, doesn't it? Where the standard model has these major tensions and fine-tuning problems, VED seems to provide natural solutions that fall right out of its core geometric idea. It doesn't just solve the Hubble and S8 tensions, it naturally explains why there are exactly 3 generations of fundamental particles, and it makes dark energy a natural consequence of the vacuum crystallizing. It's an all-in-one package. And this all brings us to one final, profound thought. This theory completely reframes the fabric of our universe. It's not a passive stage where the play happens, it's an active participant. So if the vacuum of space really is a material with stiffness and viscosity and a crystal structure, what other properties might it have? What other secrets could be hiding in plain sight in the crystal of space-time?